Okay, good afternoon, all of you. So, in today's session of class 11 physics, we are going to discuss uh, one topic, that is error analysis. Okay, the topic for today is called error analysis. Now, in some previous class, I was telling all of you that about significant figures. And during that class, I think I had mentioned that whenever you are doing any kind of measurement with an instrument, then the maximum error that you can do with that particular instrument is the least count. Like, say, for example, if you are measuring a length with a geometry box scale, okay, suppose you are measuring the length of some object, and for that you are using the geometry box scale. So in the geometry box scale, the smallest division is 1 millimeter. So if you make any error of measurement, so the maximum error will be 1 millimeter. So this is a very important concept, that so this is the first topic, that the maximum error whenever you are doing any measurement with an instrument, the maximum error will be the least count. So if you are using a geometry box scale, then the maximum error will be 1 millimeter, because the smallest unit in the geometry box scale is 1 millimeter. That is the least count. So this is a very important thing, that the maximum error is the least count. Now in error analysis, what we do is, okay, now in error analysis, what we do is that we say that suppose there is a quantity which depends on some other quantities, like suppose Z, it depends on A and B. Now, how does Z depend on A and B? So suppose if I say Z is either A plus B or A minus B, that is one possibility. Suppose if I say Z is A multiplied by B, that is one possibility. So if Z depends on A and B, then you are making measurement of A and measurement of B, and you are using those measurements to calculate Z. So if you make an error in A and if you make an error in B, then what will be the overall error? So that is the topic known as error analysis. So what is error analysis? You know that maximum error of any measurement is equal to least count of the instrument. Now you are making two measurements, right? One is A and one is B. And there is another measurement Z, but you are not actually measuring it. Z depends on A and B, like Z is either A plus B or A minus B. Or maybe Z is A into B. So the topic is that if you make an error in measurement of A, if you make an error in measurement of B, then what will be the error in Z? That is the topic, that is called error analysis. Now, the thing is that in the beginning I will tell you the proof, but after some time I won't tell you the proof, because some proofs are a bit complicated. Okay, like let's have a look at this one. Z is A plus B. So what has happened is that you have made an error in the measurement of A. So like instead of A, you ended up getting A plus something. So I'm calling that as delta A. You have made an error in the measurement of B. So instead of B, you have measured B plus delta B. And you have made an error in the measurement of Z. So instead of Z, you have measured Z plus delta Z. I mean, this you have not measured, but since Z depends on A and B, so Z plus delta Z, we can write like this. Now if you subtract these two equations, delta Z will be delta A plus delta B. Now suppose z is a minus ib, then z plus delta z is a plus delta a minus b plus delta b. Now here I want to say one thing, that in this entire chapter we are always interested in the maximum error. See, because error is not something we want. Nobody wants error. But if error were to creep into your calculations, you would always like to know what is the maximum error. That will be beneficial for you. What is the maximum error you can have in your measurement? That knowledge will be very beneficial for you. So we are not interested in error as such, we are interested in the maximum error. So the maximum error, if z is a plus b, is delta z is delta a plus delta b. But suppose if z is a minus b, then for maximum error, it will be better that a you take a plus delta a, but b, it will be better b you take it as b minus delta b. So delta z is delta a plus delta b. So I'll do one thing, I'll just write here maximum, because we are interested in the maximum error. So let's understand this. Why did I make this change? Because we want the maximum error. So if you measure a little bit extra, if you measure b a little bit less, then the a has got measured more than the correct answer and b has got measured less than the correct answer. So when you subtract it, the overall error will be the highest. So we are always interested in the maximum error. See, nobody wants an error, but you are doing measurements and it is human, what should I say, failing or fallibility or whatever, that little bit error you can make in your measurement. But it will be very useful for you if you knew what is the maximum error you can make. That means even if you make a very grave error, it won't be more than that. So we are always interested in the maximum possible error. So we can remember like this, that when z is a plus minus ib, then the error in z is error in a plus error in b. So this is number 1. Now suppose z is a into b. So z plus delta z is equal to a plus delta a into b plus delta b. So it is ab plus a delta b plus b delta a plus delta a delta b. Now you subtract these two. So when you subtract these two, ab will get cut. Delta a into delta b will be negligible small. So delta z is a delta b plus b delta a. So delta z is a delta b plus b delta a. So delta z by z is delta b by b plus delta a by a. Now this is something important. That means when you are having a product of two things, then z plus delta z is the new answer for z due to the error of a and error of b. Now when I am writing down the error of a into error of b, I am getting this big thing. Now error is something which is supposed to be really small. Like suppose if you multiply 1 millimeter into 1 millimeter, it will be really small. So error of a into error of b we will neglect. It is really small, neglect. So z plus delta z and z, if you subtract, ab will get cut. So a delta b plus b delta a is delta z. So delta z by z is delta a by a plus delta b by b. So this is called relative error. So this is the first formula, that when z is a plus minus ib, the error in a, by the way, I will not say maximum error anymore because we will only consider maximum error. So the error in z is error in a plus error in b. This is formula number 1. if Z is A into B, then it's better to calculate the relative error. So delta Z is called the error of Z, delta Z by Z is called relative error of Z. So delta Z by Z, it will be delta A by A plus delta B by B. So this is formula number 2. Now what I will do is that the rest formula, I will just tell you the formula and I will not tell you the proof, because the proof, it is a little bit advanced mathematics. So suppose Z is A to the power X, B to the power Y, C to the power Z. Suppose Z is A to the power X, B to the power Y, C to the power Z. So delta Z by Z. So delta Z by Z is modulus X into delta A by A plus modulus Y into delta B by B plus modulus Z into delta C by C. So if Z is A to the power X into B to the power Y into C to the power Z, then delta Z by Z is modulus X into delta A by A plus modulus Y into delta B by B plus modulus Z into delta C by C. This is a universal formula. We can use this formula in any question. So you can say that this is formula number 3. This is number 3. So this number 3 one, I will not give you any proof, okay? Because this number 3 one has got a slightly complicated proof. It involves calculus. So just remember, these are the formulas. So let's just summarize the theory. The maximum error of any measurement is equal to the least count of the instrument. If you have a quantity Z which depends on A and B as per the relation A plus B or A minus B, then the maximum error of Z will be maximum error of A plus maximum error of B. This is number 1. If Z is A multiplied by B, then the relative error of Z is delta A by A plus delta B by B. This is number 2. If Z is A to the power X, B to the power Y, C to the power Z, then delta Z by Z is modulus X delta A by A plus modulus Y delta B by B plus modulus Z delta C by C. This is number 3. So these are the 3 formulas which come under error analysis, right? Okay, so now I am giving you some homework questions as usual. Okay, question number 1. If S is A square B cube C d to the power minus half and the errors of A, B, C, D are 4%, 2%, 3% and 1%, then what is the percentage error of S? That is question number 1. Suppose there is a quantity S A square B cube C d to the power minus half, and if the errors of A, B, C, D are 4%, 2%, 3%, 1%, then what is the percentage error of S? That is question number 1. By the way, actually I want to clarify something to all of you, that delta Z by Z, this delta Z by Z is called relative error. If you just multiply that with 100, that is called percentage error. So you don't have to consider percentage error as a new concept. You know, like sometimes we say fraction, sometimes we say percentage. Like suppose if I say 1 by 4, right? So that's a fraction. If I say 25%, it's a percentage, like that. So this is question number 1. Question number 2. Question number 2, there are 2 rods and the first one has a length L1 35.2 plus minus 0.1 centimeter. The second rod has a length L2 16.8 plus minus 0.2 centimeter. So if you do L1 plus L2 with proper error, what is the answer, right? So this is L1, this is L2 with proper error, what is the answer of L1 plus L2? That is the question number 2. Okay, question number 3. Suppose T1 is 30.6 plus minus 0.2 degrees Celsius, T2 is 68.3 plus minus 0.1 degrees Celsius. So these are 2 temperatures. T1 is a temperature, T2 is a temperature. Question is, what is the difference of these 2 temperatures with proper error? Okay, so T1 is this, T2 is this. What is T2 minus T1 with proper error? You have to say the error also. This is question number 3. Okay, question number 4. The radius of a sphere was measured and it was found to be 5.3 plus minus 0.1 centimeter. Okay, we measured the radius of a sphere and it was found to be 5.3 plus minus 0.1 centimeter. So with this knowledge, question is, what is the percentage error in the measurement of the volume, right? So the radius of a sphere is 5.3 plus minus 0.1 centimeter. The question is, what is the percentage error in measurement of volume? So these are the 4 homework questions and you will have to submit the homework by 9 p.m. tomorrow, that is 9 p.m. Friday. So that's it for this session. I'll end the session. Bye all of you.